functions work. Okay. So we do need to be a little bit careful as we work these equations out. Always a good idea to plug it back in and see if it actually works. All right, here we go. Rational equations are basically fractions. You can see what we're looking at here. And verify solutions. That pen is totally dead, I said. Okay. So there's a couple of different methods, and one of them is proportions. And you can see here the first 4 questions are actually just proportions, where we have a fraction equal to a fraction. And if you have a fraction equal to a fraction, you can simply cross multiply to solve, okay? Now, this method also works for bigger things, too. If I want to clean up 1/10 minus 2/5, I can get a common denominator and condense that into a nice little single fraction, and then I'd be able to cross multiply. So we can use the cross multiply method pretty easily, but the idea is here we just need to get common denominators and cross multiply. So the second method, I'm going to call it using an LCD, but I actually don't like to use that name, because I would much rather, I think the easiest way to solve these rational equations is really just to make all the denominators match. If we make all the denominators match, and I love this, I'm going to show you something here. This is just math logic here. If x over 7 equals 3 over 7, what's x? X is just 3, right? Yeah, if x is 3, then they'd match, right? I don't have to do any math when I think about it, right? Okay. We don't want to get locked into procedures when it's straight up obvious. If I have something like x plus 2 over 7 equals 3 over 7, it's 1, right? Do we even have to think about the denominator? No. If I have x over 7 plus 2 over 7 equals 5 over 7, if the denominators all match, do I need to think about it? No. Okay. So what I like to do, my favorite method, is just make all the denominators match and then ignore. You can ignore those denominators, sort of. I'm going to qualify that with a little be careful statement. But for the most part, if your denominators match, we can just ignore them and look at everything else. Okay. So just to get going here, we do have, I'm going to just do like number 3 here. Here we have an easy proportion. So I have this lovely little proportion, and I can pretty easily just cross multiply to solve. So I'm going to do that. We're going to do, this is method number 1. So I'm going to multiply, cross multiply, and we're going to get d minus 2 times d minus 2 is equal to 7 times 7, or 49. So we're just going to cross multiply. What do I have to do with the d minus 2 times d minus 2? FOIL, yeah. All right, so d minus 2 times d minus 2 is going to give me d squared minus 2d, and a minus 2d is a minus 4d, very good. And then plus 4. So when we FOIL that out, equals 49. Ooh, that was slick. That was really slick. Oh, hey. Wow, d minus 2 quantity squared equals 49. That was slick. All right, what do we do from there? Square, yeah, we absolutely could. I need a different color pen here. Okay. Square root both sides. What do you need to remember if you take a square root? Plus or minus. Very good. All right, so we're left with d minus 2 equals plus or minus 7. All right. And then we would need to add 2, so we get d equals 2 plus or minus 7, which would become what? Yeah, negative 5 and 9. 2 plus 7 gives you the 9, and 2 minus 7 is negative 5. So beautiful. That's some good thinking there. I didn't think about that. Do you think we're going to get the same thing if we set this equal to 0 and factor and solve? Yeah. We would get the exact same thing, d squared minus 40. If I subtract 49, that's going to be a negative 45. And if we double bubble, we will get d equals 9 and d equals negative 5. So 2 methods, lots of methods to solve these, and they're both going to work out just fine. Super, that was fun. Let's see. Now, I like looking here. Let's look at number 6. Sure. Let's look at number 6. On number 6, this is much more complicated. We could do a lot of different things, but I'd really like to make all the denominators match. So that's what my plan is here. Make denominators match. All right. Now, if I want to make a match, I see a 4 and a 4. Can I take this third fraction and make it turn into a 4? What do I need to multiply by? Just times it by 2. So if I multiply by 2, top and bottom there, that will give me the 4. What else do I need to do? Y, yeah. I already have the 4, and if I multiply it by y on top and bottom on that second fraction, then that'll work real nice. I'm going to rewrite just so we can see what's going on here. So I have y plus 1 over 4y equals 1 times y, which is y, over 4y. And then on the last thing, I have 2 times y minus 2 over 4y. So we did a small change there. Now all our denominators match. And so I just get to ignore all those denominators, and then I just get to solve the leftover equation. Okay? My leftover equation here is y plus 1 equals y plus, what do I need to do with the 2? Distribute, yep, 2y minus 4. And then I can clean it up. Yep, so I get y plus 1 equals 3y minus 4. And then, yeah, so I have, if I subtract the y, that's going to be 2 y's. Add the 4, gives me 5. And then divide by 2. Yep, 5 halves or 2.5. Which is a great solution. Now, I have a question for you. In this problem, the original problem, there is one value that we can never use. 0. Y cannot equal 0 right off the bat. How come y is not allowed to be 0? Because if this was a 0, this would be 4 times 0, and I'd have a 0 in the denominator. Are we allowed to divide by 0? No. This is a domain problem, and we're going to talk a lot more about domain. And it's important, I like to just bring it up. We're not terribly focused on this today, but it will come up. Right off the bat, when we look at these problems, we have to be careful identifying what values are we not allowed to be based on our equation. And so when you look at this, this denominator cannot equal 0. B plus 6 is not allowed to be 0. So what value is B not allowed to be? Negative 6. So if you move that 6 over, B is not allowed to be negative 6. And this is a domain issue because it causes something totally weird. Okay? So these are things we want to look out for. What about number 3 that we did? What is D not allowed to be? 2. Yeah, D cannot equal 2, again, because that would give me 2 minus 2, or a 0 in the denominator. So we want to be really, really careful. All right, let's look at, let's look at 8. It looks crazy. Again, I'm going to use the make a match technique, all right? But right off the bat, what is k not allowed to be? 0. K cannot equal 0. Again, if we made k 0, we'd have 6 times 0 squared, which is 0. We're not allowed to divide by 0, so that's a no-no number, okay? Now, again, make a match. Here, my denominator's already matched. What do I need to do up front here to make a match? K squared times by k squared on top and bottom. So I can make a match. And I'm going to rewrite now. Do my denominators match now? Yeah, they're all 6k squared. So I get to ignore them once I've made them match. I can ignore them. And now I'm left with k squared plus k squared plus 9k plus 20 is equal to 2k squared plus 11k plus 15. All right, what happens here? Yeah, so we get these k squareds are really 2k squared and 2k squared. That just cancels out, doesn't it? That's kind of nice. So 9k plus 20 equals 11k plus 15. Subtract the 9k, we get 2k. And subtract 15, we get 5. Yeah, and we get 5 over 2. Again, crazy. That was just a coinky dink thing. No. 5 over 2. Sorry, that was a weird circle I drew there. All right, that works just fine. All right, questions so far? Do you like to make a match technique? All right, so it works really, really well when we have a monomial in the denominator. Monomial is what? One term. This is a one-term thing. Versus the next page. Up here, these are not monomials. This is a binomial in the denominator. 2 terms in the denominator. 2 terms. These, we can use the make a match technique, but we must factor first. All right, so I'm going to factor my denominators and then make all of them match once they're factored. So m squared minus m, I want to factor that. What can I take out of there? An m. There's a GCS. So when I take out the m, what's left behind? M minus 1. Very good. Now, m minus 1 here, that's already a factor. It's its little factor, m minus 1. And in our third fraction, we have m squared minus m. So again, if I were to factor it, yeah, m comes out and I'm left with m minus 1. Now we just need to have each little part. I want the m and I want the m minus 1. I want the m and I want the m minus 1. So I have each little part there. So what do we need to do? How do we make a match? Multiply the middle by m on top and bottom. Now they each have a green and a red factor. A green and a red and a green and a red. Do the denominators match? Yeah. Yes, they do. So I get to ignore them. But before I ignore them, can we write down, now that they're factored, what values is m not allowed to equal? 0 and 1. Yep. So if I plug in a 0 there, 0 times the whole thing is 0. If I plug in a 1 for m, 1 minus 1 gives me a 0. So there are 2 values right off the bat m is not allowed to be. And pay attention to that. All right, so now that our denominators match, now that we know the values m is not allowed to be, I'm just going to write the rest of my equation here. 1 plus m equals 6. What means m is 5. Hey! That was pretty slick, wasn't it? Great. Okay. That was easy. Let's look at 13 and 14 are the last two we're going to do. All right, 13. I have a trinomial. What are we going to do first? Factor first. Factor first. All right, z minus 5 is already a factor. But this trinomial, I think I can double bubble that. Z times z is z squared. What times what gets me a positive 10? Negative 5 and a negative 2. Beautiful. Negative 5 and a negative 2. And then 2 is its own little factor as well there. So there's a green 2. There's a red z minus 5 bubble. And a black z minus 2. We need all the colors. I need a red, I need a black, I need a green. So what does this first fraction need? Z minus 2, I got to put on a z minus 2 top and bottom. That's a z minus 2 top and bottom. And what else does it need? The 2 as well, the green 2 as well. So I got to put on the green 2 top and bottom. What does the middle fraction need? The 2 top and bottom. So we're going to multiply top and bottom by 2. And now the last fraction needs what? Yeah, z minus 2 on top and bottom. And z minus 5 top and bottom. All right, now everything has a green and a red and a black. And a green and a red and a black and a green and a red and a black. Our denominators match. But before I go any further, what are all the values that z is not allowed to equal? 5 and 2. Those are, if I plug in a 2 there, 2 minus 2 would produce a 0. That's no. And 5 minus 5 would produce a 0 in the denominators. That's not going to work. All right. Our denominators match, so I am just going to rewrite everything. So this turns out to be 2 times z minus 2 is equal to 2 times 1, which is just 2. And I have a minus. Ooh, tricky. And then I have z minus 2 times z minus 5. I'm going to be real careful with this negative. In fact, I'm going to make sure that I just multiply first and then distribute in my negative. I'm going to distribute my 2, so I get 2z minus 4 is equal to, what do I have to do back here? FOIL, yep. Got to FOIL that out. I'm using brackets because that negative changes everything behind it. All right, what do I get when I FOIL my bubbles together? Minus 7z plus 10. Very good. Negative 5z and negative 2z gives us our negative 7z. And then what do I need to do with my negative? Now we distribute it in. Going to be very careful there. So we have 2 negative z squared, positive 7z, and then a negative 10. So all the signs change. Be very careful. All right, how do we solve from here? Put them all on one side. What side do I want to move them to? I want to move them to the left. Mostly because this guy right here is negative. I'm going to move everything to the left. All right, because everything needs to be set equal to 0. So I get a positive z squared. I have to subtract 7z, so 2z minus 7z is negative 5z. I have to add the 10, which would give me negative 4 plus 10 is 6. I also have to subtract 2. So I get 4. All right, lots going on there, so sorry. Did you follow it? Do you have a question? Okay. All right, and then what do we need to do? Double bubble. Double bubble. Z minus 4 and z minus 1. Good, good. Negative 4 times negative 1 gives you that positive 4, which means Z equals 4 or 1 for our answers. And again, you can check by plugging them back in. Always a good plan. All right, last one, number 14. I see binomial. What do I need to do?
Question.
Yes, question.
Isn't it supposed to be opposite for that? Why is your 4 negative?
No. That Z minus 4.
Okay, I thought that was like.
No, yeah, that's this. That is a Z minus 4. I don't know what's on the paper. It's not reason. But yeah. So yes, it did turn. Yeah. Factor first here. So I am going to factor. Factor first. My denominator, u cubed plus u squared. What can I do there? Pull out u squared, GCF. U squared comes out. What's left behind? U plus 1. Good. Oh, and hey, look, there's a u plus 1 right there. That's nice. And hey, that u squared matches this u squared. Fantastic. So I have a red factor and I've got a black factor. What do I need to do here in the middle? U squared on top and bottom to make a match. And what do I need on my last fraction? A red u plus 1 on top and bottom. Fantastic. So now they each have a red factor and a black factor. Before I go any further, what is u not allowed to equal? Negative 1 and 0. Good, because 0 squared would make the whole thing 0. So those are the two right off the bat, not allowed to equal. Good, good, good. Okay, do our denominators match? Yes, they do. So that means I can ignore them. And I'm just going to leave you with a 1 subtracting u squared is equal to, I'm going to go ahead and distribute my 3. 3u plus 3. Good so far? All right, now how do we solve? Move everything over to the right. Very good. We're going to move everything to the right so that my leading term is positive. So I'm going to get a positive u squared plus 3u. And then I have to subtract the 1. So 3 minus 1 is 2. What? Sorry, my arrow is not in the best spot. There we go. That's a little better. Plus 2. Yep. And then we need 2. Double bubble. So u times u is u squared. What times what is positive 2? 2 and 1. 2 and 1. That's going to give me a positive 3. What's wrong? Oh, you're ahead of me. Good. So u is supposed to equal negative 2, or u is going to equal negative 1. But yeah. Can u equal negative 1? No, it cannot. That is a false solution. That one is not going to work. And that's why we want to check domain. Okay? Make sure you're paying attention to the domain. So it is just the one solution here. So as you're working through on the Delts math, you got to be very careful, okay? Got it? So the techniques are cross multiply or make a match. Make the denominators match, which I like. Okay?